Okay, geometry naturally. I have everything over to the cloud and Dropbox. Deleted a lot of videos, and let's go again. So yes, we have all the answers on here, but try not to pay attention to them. Let's go slow through this, and I'll describe what's happening. Here we go. 4.1, triangle sum properties. Okay. Yeah, this is the same old all three angles in a triangle up to 180, but this is when we actually apply it. Also, I can classify triangles by sides and angles, and I can find interior and exterior measures. Okay, so that's your new word for today. So here we go. Classify each angle as acute, right, or obtuse. So if you have a 90-degree angle, that's right. If you have a 72-degree angle, that's acute. And if you have a 116-degree angle, that's obtuse. So I'll go a little slow. If I'm going too fast, because all the answers are written here, pause it, write them in, and then go back. Okay, so I do apologize. Now, how do you know that angle 4 is congruent to angle 6? Well, this comes from last chapter. I have a set of parallel lines. How do I know? Because of these arrows tell me that two lines are parallel, cut by this transversal. These are called alternate interior angles. So alternate interior angles are congruent. And if we started with these angles being congruent, we would use the converse and say the lines are parallel. All right, so we have a little activity here. It's page 206. And I know you see a line here, but that's just kind of how I made it. So we're going to start with a triangle, and we're going to label 1, 2, and 3. Tear off the three corners and place them next to each other. Okay, so here we go. So I'm going to try to tear off. Here's angle 3, angle 1, and angle 2. Okay, so yeah, they're next to each other, but let's really put the angles next to each other. So watch this. This is kind of cool. I'll tape them on here afterwards. What do you notice? The three angles make a straight line. Isn't that pretty cool? So how many degrees in a straight line? 180 degrees. So that means if you take angles, I knew that was going to happen, the static angles 1, 2, and 3, you can line them up and make a straight line, 180 degrees. So that's my conjecture here. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Okay, now, part 2. Cut out a triangle. Label it ABC. The reason why we're labeling ABC is so we can keep it separate from that one. And we're going to be talking about an exterior angle here. So let me tell you what an exterior angle is. If you take a triangle and extend any side, the angle that's made on the outside is called exterior angle. We can extend this side, exterior angle. Extend this side, exterior angle. So the interior angle and the exterior angle make a straight line. They're supplementary linear pair. So here we go. Cut out a piece of paper, label the corners. Tear off just A and B. Okay. So I tore off just A and B. Place them next to angle C, the exterior. Okay, so remember this was my triangle. Here. You know what? I'll put that outline back on there so you can kind of see it. So here's my triangle. So tear off A and B and put them next to it. And what do you notice? I mean, it's the same idea of what we did up there, just a little twist. Okay, so that means these two angles will equal the exterior angle. So I'm going to tape that on there so I have it on there forever. So you might want to grab some Post-it notes. Follow through. Oh, look what happened with the static. Okay, so our conjecture. Angle A plus angle B will add up to equal the exterior for angle C. And again, that's going to come up in the future. Next page. Yeah, this is 5 pages. This is the long one. All right, here we go. So this is a little bit of definitions here. You probably know them. You may remember them or familiar, but here we go. A triangle with vertices A, B, and C is called triangle ABC, or you can make a triangle ABC, kind of like how we had an angle and stuff. And it doesn't matter which one will come first? Usually they do it in alphabetical order. So you could put, this is the same as triangle BCA, triangle CAB, triangle CBA, etc. All right. If all three segments are different in a triangle, it's scaling. If you have two sides that are congruent, it's called isosceles. And if you have three sides that are congruent, it's equilateral. Okay, so that's classified by sides. Now, if we classify by angles, if all three angles are small, it's an acute triangle. Okay. If we have one right angle, it's a right triangle. If we have one large angle, it's obtuse. And if all three angles equal the same measure, it's equiangular. It just so happens that these two are the exact same, well, similar triangles. They have congruent sides and congruent angles. Okay, example 1. Classify the triangular shape of the support beams in the diagram by its sides, measuring its angles. Okay, so I don't know if you could tell what this is. This is like one of those electrical towers. And I tried to make thicker lines here. I don't know how it photocopied. You'll have to let me know. So these two lines are congruent, and we have a big angle. So if you have two congruent segments, it's isosceles, and then measuring it by the angle, it's obtuse. Now example 2 is the one that you might want to copy and then pay attention. So, or I would say go ahead and use your program for the distance, because you have been tested on it, now you just use it, okay? So we have a triangle here. The ordered pairs are shown. They're kind of tiny, so be careful. You want to find the distance of all three sides. The reason why is because we want to classify it according by its sides. So when I found the distance of CA, that's this one, I got square root of 194. And when I found the distance of AB, it's this one, I got square root of 157. And then the distance of CB is square root of 85. So you might want to pause it right now. All three lengths are different. I don't have to find the decimal point to see that. It's going to be a scaling. So you might want to pause it and do the work. Check it to make sure you got the same thing. Now, determine if this is a right triangle. Well, how can you tell if you have a right triangle? Well, if you have a right triangle, you're going to have perpendicular lines. And how can you tell if you have perpendicular lines? Remember before, if you have parallel lines or perpendicular lines, parallel lines have the same slope. Perpendiculars will have opposite reciprocal slopes. This could be an example. Okay, so I found the slope of CA. To go from here to here, I had to go up 5 over 13. That's why it's in red. So the slope here is 5 over 13. To go from C to B, I had to go down 6 over 7. So that's the slope. And then to find here, I just slid over. I went up this many over that many. So up 11 over 6. Notice none of them are opposite reciprocals, so it's not a right triangle. So far, so good. So again, that's like the longest part of this whole video. All right, next page. It goes fast from here. So here's our definition of exterior and interior angles. If the angles are on the inside of the triangle, they're interior angles. If you extend the sides and it forms a linear pair with an interior, that's called exterior angle. So here we have 3 exterior angles. And yes, I could extend this line right here and also have an exterior angle right there. But what do you notice? These two are vertical pairs, so they will be the same measure. So it doesn't matter how you extend the line. You'll still have the same measures for that. Okay, now the next 2 theorems will tell us how we got the activity, or basically sums up those activities in the beginning. The sum of the measures of the interior angles is equal to 180. So angle A plus angle B plus angle C. So they have A plus B plus C equals 180. Here's a proof. Now I'm just going to kind of guide you through this proof. Please do this on your own. We have given triangle ABC. We want to prove that the 3 angles add up to equal 180. So that might be hard to see. Is this better? Yeah, it's better. All right, so here's your plan for the proof. Draw an auxiliary line through B parallel to AC. So here's AC, and I drew an auxiliary line parallel, okay? And then show that 4 plus 2 plus 5 equal 180. So these 3 angles will equal 180. Okay, it's not a linear pair, but it does make a straight line. And then show that angle 1 and 4 are congruent. Why? See these 2 parallel lines? Cut by this transversal, alternate interior angles. And then 3 and 5. we have these two lines are parallel. This is a different transversal, so 3 and 5 are congruent. Then by substitution, you'll get it. Okay, so go ahead and follow that proof. It's pretty nifty. I like it. All right, next page. Here's our exterior angle, the other part. Okay, so say angle 3 is our exterior angle. These dots that I put in here are my interior. All three of those are interior, but these two are called the remote interior, meaning they're the furthest away. They're not the linear pair with the exterior angle. So the remote interior angles. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So meaning angle 1, some measure of angle 1 plus a measure of angle 2 equals a measure of angle 3. It's hard to see. I have pretty colors here. It's all color coordinated. Let's do an example of that now. Okay, example 3, and again, the answers are all here, so bear with me. Here's my exterior angle. This is the one that's right next to it, the linear pair. So here are my two remote interior angles. The sum of these two will equal to the exterior. So I have the exterior, 5x plus 13 equals, my two interiors are 4x plus 2 and 2x minus 9. Combine like terms, so I'll get 6x minus 7, and then solve for x. Subtract 5x on both sides, add 7 on both sides, x is 20. Now you always have to make sure that you're going to answer the question. It does say find x, but if you don't read the rest of it, it can be a problem. So we know x is 20 degrees. Now then the measure of each angle. So not only do you need to find x, but I need to find this one. So substitute 20 for x. 5 times 20 plus 13 equals 113. 4 times 20 plus 2 equals 82. 2 times 20 minus 9 equals 31. These two angles, the remote interior angles, will equal the sum, or the sum of this will equal the exterior. All right? Corollary. A corollary to a theorem is a statement that can be proved easily. So much for me fixing this. Using a theorem. So the corollary below follows the triangle sum theory. So here we go. Remember what the triangle sum theory says. Measure of angle A plus a measure of angle B plus a measure of angle C equals 180. So this corollary says the acute angles of a right triangle, that would be these two angles, these are the acute angles because that's the right one, are complementary. Let's see why. Well, we know measure of angle A is 90 degrees, that's my right angle, plus angle B plus angle C. So basically I just substituted that in. Subtract 90 on both sides, measure angle B plus measure angle C equals 90. So your two acute angles will always have to equal 90. So the next page we're going to apply that. So this is a right triangle. That means these two will add up to equal 90. So 2x plus 1 plus 5x plus 5 equal 90. Combine like terms, 7x plus 6 equals 90. Subtract 6 on both sides. You'll have 7x equals 84. Then divide by 7. Again, sometimes you only need to find x, but they want each angle. So substitute 12 in for x. So I have 2 times 12 plus 1. You get 25. And then 5 times 12 plus 5, you get 65. Yes, these two add up to equal 90, because 90 plus 90 is 180. Okay, this one should not have had anything written in there, but if you do, it's not a big deal. The support of the skateboard ramp shown forms a right triangle. Okay, it's the skateboard ramp, I guess. The measure of one acute angle in the triangle is 5 times the measure of the other. So here's one angle, and here's 5 times the other. Find the measure of each. So these two have to add up to equal 90. So 5x plus x equals 90. Add them up, you get 6x. Because remember, there's always that 1 there. Divide both sides by 6, you get 15. So each angle is 15 degrees. Well, sorry, x is 15. So that means this is 15, and this will be 5 times 15, which is 75. Here's our homework assignment. And this is proof triangles. So I'm not really sure why I don't have that on there. Here's my other sheet. Okay, if you have any questions, please ask, and have a nice evening.